Hello and welcome to today's webinar, Simulation, Autodesk CFD, Thermal, or Fluid. This is Marcia Tucker, Simulation Specialist at Applied Software, and I'm delighted to be your moderator today. And we have asked our Simulation Specialist partner Master Graphics to join us on this webinar. They're located in the Upper Midwest and also have great longevity in the Autodesk channel. Throughout our presentation, we encourage you to interact with us by typing in questions, and in the questions pane, by the way. We'll be answering all questions at the end of the presentation. This webinar will be recorded, and the follow-up email will contain the link, and you'll receive that within a few days after the webinar. So, Mark Huntoon has, with Master Graphics, he is a PE and holds numerous engineering degrees and the simulation specialist there. And Mark, if you'll flip to the next slide. We have a company called Live Lab Learning, and that is where you attend class from your desktop, but it is live and not recorded. You can go to our website and check out whether you want to take classes in product design or building design or utilities and civil infrastructure. And our next slide, it would be, we do have an upcoming webinar where you can learn how to improve your digital prototyping workflows with AnyCAD, Nastran, NCAD, and Vault. That will be held July the 30th, 2015 from 12:30 to 1:30, and that's Eastern Standard Time. If you have any questions, you want to know more about that, please call me at 404-564-1870 or shoot me an email at marcia@asti.com. And I think this will be where what's on our next slide, Mark? Yeah, I'm going to turn it over to Mark now, and he can share his expertise. Thank you.
So, good morning. Once again, my name is Mark Huntoon, and I am with Master Graphics. Today, we're going to briefly talk through Autodesk Simulation technology. Then I'm going to talk about the specific product, Autodesk CFD. I'm going to show you a couple things within the software, and then we'll kind of wrap it up and go from there and answer any questions you may have. So with Autodesk Simulation, the goal is to help you make great products, and we like to focus on three words: validate, predict, and optimize. With Autodesk Simulation, you can validate the adequacy of and safety of your product before it ever hits the manufacturing floor. You can create digital prototypes. By creating digital prototypes, you can greatly reduce the need for physical prototypes to predict the performance of your product. Autodesk Simulation empowers you to optimize your design and make great products as well. So by taking these three together, we come up with what's called digital prototyping. When you move the simulation up in the design process, this allows you to create more great products more cost effectively. And to do this, Autodesk has made some major investments in simulation technology, starting way back in 2005 with Solid Dynamics and then Plazotech. Both of these form part or 2/3 of Inventor Simulation. Next was RoboVat, which is also kind of part of Inventor Simulation, but it's also the structural analysis software. Later on, they picked up MoldFlow and then Algor, which makes SimMech. The one of interest today is CF Design, that they bought from Blue Ridge Numerics, which now creates Autodesk CFD. And then recently, about a year or so ago, they purchased NEI software, and that allows them to have the Nastran capabilities and the Nastran solver and the mechanical. So all these products come together to create the portfolio of products. So you have the structural mechanics through Autodesk Nastran NCAD. There's the standalone Nastran solver, as well as simulation mechanical. What we're going to focus in on today is the flow and thermal analysis out of CFD, and CFD is computational fluid dynamics, where it's basically a finite element program that allows for the movement of fluids. And a fluid is anything that's not a solid, so it's an air or a gas or a liquid or even something somewhere in between. There's also the flow design product that's available. As well in structural engineering, they have the Robot Structural Analysis Professional. They can optimize molding processes through the MoldFlow and analyze them using the Helios products. So let's focus in on Autodesk CFD. So the goal here is that we can reduce the time to market by utilizing this product. You can optimize the material costs and the design features. You can improve quality and reduce defects. You can obviously do digital prototyping, which reduces your physical prototyping and obviously the cost associated with that. It creates a lot of collaboration because everybody can see what you're doing, as we'll show. These are the features of the software, how easy it is to see. You can increase your product innovation and provide a virtual performance, which is something I'm going to show, a really neat feature in the software. But there's some misconceptions around CFD software that it requires a specialist. But with Autodesk CFD in the design study environment, you can have great analysis power, but you also have the ability to review this data in a clearer way for the non-PhD. So part of this comes from the design study environment. This is really what makes this program so great. It has a multi-CAD data exchange, so it can pull in information from many different CAD software. It has a great link directly from Inventor or Pro-E or SolidWorks. You can do a design study where you can automate and show what's going through. It has the multi-scenario design review center, which will show you that as well. It has some great material databases, and you can visualize the results in a really neat way. So there's 3 flavors of solvers that are available with CFD. The base solver has the following capabilities for fluid flow, which are shown on the on the left-hand side of your screen. So you have your laminar and turbulent flows. It can handle incompressible fluids and do things in a steady state. For heat transfer, it can do conduction, it can do convection, whether forced or natural. If you move up to the next level, which is the advanced CFD solver, now you can get into compressible materials or fluids. You can do transient analysis, you can do mixing, you can do cavitation and radiation, the solar loading that's a valuable asset to those in the building market space, humidity, current, and voltage. And the last level is the top level, which is the CFD motion. And this adds the capability of adding in a rigid body motion. So if you have an impeller or something moving through the fluid and you want to see the effects of that. So we can do linear, angular type motions. We can combine those. We can do orbital motions. We can even do unconstrained motions. So there's a lot of power there. For those that are in the architectural and MEP applications, we can do the solar loading, like I said. We can do 2-phase flows with humidity and steam. And then we can do thermal comfort as well as smoke. And actually, I saw a very neat demonstration where they did a smoke analysis through a parking garage. So if a car started on fire, what would be the effect of it and how all the smoke would get out of there. So it's a very powerful and helpful tool. So now I want to walk through a couple things. Let me switch over. So here we have a muffler, and this is an Inventor model. And the muffler, basically there's a design study that's going on, and you have these 2 plates that are here and here. Let me just turn this just a little bit. And you have these holes, and so right now this is showing the large hole configuration, and then they have a small hole configuration. So we want to run this analysis, and we want to see what happens if we use the large hole and what happens if we use the small hole, and run it for 2 different engine operating speeds. So to do this and pull this information directly from the CAD system, especially Inventor, we come up here to the Simulation tab, and I can press this Active Model button, and I'll push it right over into CFD. And if I have all of my material information there, it pushes that along as well. So going to CFD, you can see that here's the model that I've been brought over. To set up the analysis, basically we work from left to right. So we have some geometry tools, and then you have your materials, and you click on materials here, and you can come over to edit. And I just want to show this real quick so that these are all the different types of materials, groups that they have put together. So starting with a fluid, you can select all air, you can select butane, ammonia, gasoline, anything that's moving like a fluid, whether it's in a gas state or in a liquid state. The next is solids. So you can put in all different types of insulation materials as well as steels. Then you have the ability to put in resistance. We can actually have built-in fans that can be applied, blowers, valves, compact thermal models, which act as processors if you have that type of thing, heat sinks, heat exchangers, LED devices, just a large number of different materials that you can use. Plus, you have the ability to go in and actually create your own. By switching this from default to my materials, I can come in here and create anything I want, whether it's a solid, a fluid, or any of the other material types. But in this model, we've gone through and we've basically split everything up into stainless steel and into air appropriately. So the next thing we would do is we go through and we set up our boundary conditions. And with the boundary conditions, I can specify velocities, flow rates, pressures, temperatures, humidity, so on and so forth. And that's based on that I'm picking a surface. If I switch to selecting a volume, this creates a slightly different group where I can generate a total heat generation or just a heat generation. Now, for this model that we've done, or that I've brought up here, what we did is we've set up, okay, there we go. So we've set up a film coefficient, and then we put in some volume flow rates that is basically, air moving in at a certain temperature at a certain speed. And then we specified the pressure as 0 to basically make sure there's no stops and allow free flow. It also allows us to see any pressure drop if it exists, or what the pressure drop is. If we were doing a transient analysis, then we could set up initial conditions here. But in this case, this is a steady state, so we don't need to do a transient. Next, we come up to mesh sizing. And this is where you can either set up your mesh automatically or manual. Typically, I run off of the auto size, and then I'm able to come in here to the edit. And if I pick an object, it allows me to actually come here and use the slider to create a finer or a coarser mesh for a certain area. Depending on what the type of analysis you're trying to do, you can adjust this and then run it. The last thing here is we have the motion. If you have a rigid body moving and you have the need as well as the motion solver, then you press on this button to establish any rigid body motion. So the next thing I wanted to show is you move on to the solve, and you can open up the solve tab here, and it creates this dialog box. And this is where you specify whether you're going to do steady state or a transient analysis. You can specify where you're going to solve it, and you can specify your number of iterations. On the next tab, this is where we specify if we're doing a heat transfer and our flow and what those types are. And so this gives you the ability to just run a flow analysis or just run a thermal analysis or to run both of them. And there's a way that you can actually adapt your solution where I'll run the flow analysis and then heat transfer later. So I've already gone through and I've run this model. And so now you can pull up the results. And what we have here is basically a temperature gradient. And so you can see the different temperatures that are applied to the stainless steel on the outside. And I can specify different things in here, but we're not really interested in just one. So I want to show you the power we have here. So by going to this tab of the Decision Center, I can pull up all 4 different options. So if what I'm interested in is external temps, so I can double click that. Let me change my view here so that I have 4 views. And then I can come up here and I can put all of these in to each one of these, and I can compare them side by side. So here are my 2 small hole scenarios at 800 RPM and 2400 RPM, and the large holes at this 2 speeds. And I can compare those. Let me minimize this. It gets a little bit easier to see. I can also show all the vectors inside, and vectors are a very neat, powerful thing. If I zoom in, you can also see when I zoom in on one, the other 3 will zoom in as well. So this is actually showing me where everything is moving. So in this case, we're looking at temperature. So we're looking actually at a heat flow going along. I can look at static pressures. And then another neat feature is we can actually do an iso plot. And this is an isometric surface, so I can actually sit there and slide and adjust to a different temperature, and it will show me everywhere in that volume that is that temperature. So, you know, this is the temperature of 360 degrees, for instance. And you can see, I can see it in all 4 of them. I can also do traces, where I pick a point, and you can see the traces coming through and showing me how the air is actually flowing through the muffler. And one thing I'd like to be very, very clear on is I'm showing this in the Decision Center, but you can do all of this in the Results tab in the normal design tree. It's just more helpful to see this, obviously, in the to be able to compare the 4. And it looks like it kind of messed with my frame. So let me do this real quick. Let me pop these back up so that we can see all 4, so we can see the variances. Or better yet, let me do this. This is what I wanted to do. So here are the 4 isometric surfaces at 360 degrees. And you can see that obviously we have the most volume of heat running at the highest speed at 360 degrees with the large holes. We can also put in a summary plane where it'll give me data for all 4. If I pick something, for instance, this is flow rate and pressure so that I can compare them. But I can also plot that information as well. So this gives you great power. It's very easy to set up. We can teach you very quickly how to do it. And then it gives you great information when you come back to look at it. So I find this very helpful. You don't need to be a PhD to run it. And the information can be very valuable and you can build off of it. So the next thing I want to show you is actually a new feature that just came out last year. So here we have this tank. And the tank is surrounded by a steel body, which we've removed the steel body because we really doesn't matter to us. And we've gone through, we've set everything up as water, for instance. We really don't have any boundary conditions, but we set up an initial condition of height of fluid. So basically we're setting our height of fluid basically at this point. We put a plane, a work plane in our Inventor model to basically separate the two, but we're still calling it all water. But what we're saying is you have water at this level to begin. Well, when we go into the Solve tab, if we go to Physics, we press this button here called Free Surface. And here we've actually applied, let me just get it on my screen, we've actually set up an acceleration. And so let me plot that, and then you can see this is the acceleration that happens over 1.5 seconds. So when we run this, and it takes a little bit to run it because it is a transient analysis steps through, we get this body, which doesn't seem real exciting, but the first thing I'm going to do is right-click, and I'm going to turn on Free Surface. So now it's showing me basically what is the surface of the water at this given point. And because it's a transient analysis, I can do it over a period of time. So let me turn on the animation, and let's play it. And you can see that the waves are building as it's being pulled forward, and we can actually create a wave surface that changes over time. And I did this for this tank, but obviously it can be done for filling a body or a volume. I've seen it done for boats. I've seen it for a lot of different applications. But it's a very neat visual, and it's very powerful because I can also go through it any time. And it seems like the important time, or the time of most interest, is coming in right about in here. And I could pause and take this time step and then go into simulation mechanical for this tank and turn off the fluid. Kind of funny that I'm turning off the steel for CFD and turning off the fluid when I go into Sim Mech, but I can actually pull these pressure forces from the water into Sim Mech and run my analysis. So it's a very, very powerful feature, and it's something really neat to show off to your boss. So it makes you look like you're really working hard, which is what we all want. So let me switch back here to my presentation. So there's a couple things that are new with Autodesk CFD 2016. other than the name, they switch it from Simulation CFD to just CFD. It's now faster and lighter. There's a new graphics engine that delivers significant improvements in terms of the visualization, as well as there's a scalable solver. So they put a couple different solvers in there to improve how you can do it. You also have the ability, depending on what your license structure is set up as you're able to actually send it to a solving server. They've also improved geometry and meshing through 3 things: the Model Assessment Toolkit, the Sim Studio tools, and then the Automated Surface Wrapper. The Model Assessment Toolkit, you can run this directly out of Inventor or out of your other CAD software, and it basically will go through and finds any issues there might be with your geometry, and then helps you improve them and fix them and clean them up before you move it into analysis. There's also Sim Studio tools. This has the ability, it's actually a modeler, so you can, or a modeling engine, so you can actually model a new part through this. But the really powerful thing is it can actually go through and do a simplification and defeaturing. And it's just a matter of pushing the button and it defeatures and simplifies your model. So if you have a very polished final model that gets sent to you and you need to do your analysis, you basically can click a couple buttons and it will basically take all those features and anything that would slow down your analysis for you. We also have what's called the Automated Surface Wrapper. And basically what it can do is take almost any solid or surface geometry and basically fills in any gaps that might cause problems. So it goes through and it can dramatically improve how fast you can solve your analysis, as well as it speeds up the entire process of the prep work in the pre-processing stage. They've added some expanded physics. They now have the direct solar energy transmission. This is really obviously big for our friends in the building space. But they've also added in the turbulence models. They can do the airfoil, or they can do the cyclone separator in case you wanted to model your Dyson vacuum and see why it works so well. So at this point, I'd like to quickly talk about training and learning. There's the live lab that Applied Software has, and obviously I would work through that if you wanted training. We have a 2-day class as well as mentoring that we can provide for you. I also like to point out that there's simhub.autodesk.com. This is where you can go to find out more about simulation software. You can ask questions. You can see different events going on. There's forums. So even if you can't reach me or you have a quick question, it's a great place to go to find out more information. So at this point, I'll ask and see if there's any questions, and I'll also turn it back over to Marcia if she has anything else she wanted to add.
Right. We have not had any questions submitted at the point right now. So some of the information you shared, Mark, is really interesting, and not even being an engineer, I found it very fascinating. So if you have a question, if you would, please type it in the questions pane. That would be great. So it would, anyway. We do want to thank you for joining us today. We hope you found the webinar informative and a help to your business. So again, my number is 404-564-1870. Thanks so much and make a great day. Bye-bye.